Okay, so I just got done showing you how to do about the frequency distributions that correspond from a frequency distribution table, and how to find the corresponding histograms that would like to write them. So we noticed that distribution for those guys, none of them changed. The same distribution shape. The only thing that changed was the scaling and the adjustments. How do we find the new adjustments and scales for it? Because they all represent something different. So right here we get to the idea of cumulative frequencies, and we're also be hitting onto that the concept that the witness talk about, which is orgive, or some people might refer to as ogive, whichever the correct pronunciation is. But that's what we're going to do here. So we're going to find out the ogive is very similar to polygon, but instead of making it come down at the end to make a mountain, it stops at peak. And also, instead of being midpoint, it's actually supposed to be the real, it's supposed to be the bottom points that correspond to the upper real limits of each interval. Okay. We'll see how that's working and in that regards. So let's go ahead and get to this frequency distribution. So notice how, once again, I'm keeping the parameter that has the same table measurements and I have frequencies. So instead of finding multi-frequencies, I'm going to go for cumulative frequencies. But first of all, before I even do cumulative frequencies, we have to understand what is cumulative frequencies. What does that really mean? We should have all experienced, in one of our classes, a teacher say, hey, our final exam is going to be cumulative. Okay? And when you first heard of that, what do you mean by that? And he said, well, it's very simple. Everything that we covered the first day of class, all the way to what we covered before we review for the final, it's going to be an exam. So everything from the first day lecture to last day lecture, before reviewing, is going to be a final exam. So he adds up all those concepts and put it into one chunk, into one result. So say what happened if he would have done it and said, oh, let's say you guys know, keep in mind that also my exams are cumulative. Each of my exams. So if I have 4 exams, and then the final, what he's really saying here is, the first exam, well, that's pretty clear. It covers everything from day 1 all the way to the lecture before you start reviewing for the exam. Okay. While we do exam 2, it says, it doesn't mean stop after exam 1. It says, I'm going to get what happened from the first day, and I'm going to add it up to what we covered up until the week or the lecture before reviewing for exam 2. Exam 3 is the same thing. Instead of being those after exam 2, he says, no, I'm going to start from the beginning again, and I'm going to add everything up together, combine it on to one exam, and it'll be everything from first lecture all the way to the lecture before reviewing for exam 3. And that's why he does it. Okay? So the same thing's happening here in reality. But instead of being exams and concepts, we're talking about measurements. That's what we're talking about here. So when it says final exam, or final measurement, or interval, it says that, well, we have to better add up all these guys. But how do I put up until I get to that? That's the question. Because we're doing them by parts. That's what's really happening here. That's the true mechanism. So, one thing we really have to understand here is, well, these guys are not the real limits. Keep that in mind. That means that there could be values between 2 and 4, 24 and 25 that may exist depending on how type of measure we have and how we measured it. So we should understand that the real limit is not this guy, but it's really this one. That's what it really is. So what we're saying here is, I want to get all the frequencies of all the measurements that are less than the real limit, which is 25. Not 24. Now we go to the first one. I'm going to repeat the same idea. Well, for this interval, note that this is just the upper limit, not the real upper limit. The real upper limit is the corresponding, or the preceding class's lower limit. So what we're really saying here for this interval, if I want to get the sum of everything below, I want all the values that are less than its interval real limit, which is 40. And if the 40 will be included and added up. We'll repeat the process again. For this interval, this is not the real limit again, this is only the upper limit. The real limit is over here. So we're looking at less than 55. And I repeat the process again. Less than 70. And over here, so understand the upper limit is actually supposed to be 85, like I said before. So over here would be less than, and we're looking at 85. One thing I want to put as already know, and that's pretty much kind of look over here. Hey, well, this measure started at 10. Well, could we say that there's a frequency for all bodies less than this lower limit? And that is true. But actually, we could think about all the ones below it. And what we're seeing here, as a side, we're not going to put this into our list for right now, but this will be where we look into when we're graphing, because it's important. So we're saying, well, what about all the values that are less than the lower limit that we have, which is the limit of everything else? Well, that has to be taken into consideration. And we have to see here, well, is there any scores less than this interval? No. So the frequency happens to be corresponding to 0. And we'll see that later on when we actually graph it. It will be over on frequency is 0, and then when we come over here, the cumulative frequency itself will actually be 0. Okay? But let's just build the cumulative frequency and see how it's done. Where is it coming from? And hey, is there a shortcut? Yes, there's a shortcut that we could use by hand and also in calculator technology. We could just do the process pretty simple with addition, and also there is a function, a formula that does it using list operations. And we'll see that. So come back over here. Well, since there is no interval less than the first one, all we know is that all values are less than 25. This happens to be those that are in the frequency or in the interval. So it's going to be 6. We bring 6 over. Now, and that's what we got here. That was my main focus. Now, if we want to get to the next interval, remember, it's everything that is in its interval and below. That's what we're saying here. So if I want to find out what this value is, I'm going to sum all those that are in this interval and below with the measurements. So we're looking at 6 plus 7, which is 13. I don't read the process. If I want to find the cumulative frequency for the third interval, remember, it's all values are less than 55. So what are values less than 55? All these guys are here. These are all less than 55. Look at that. Notice that. So we're looking at all those intervals. So come over here. We're looking at these frequencies right here. So when we add those guys up, 6 plus 7 plus 4, we're going to end up getting 17. And once again, I'll repeat the same process again. All values that's in 70 are its current interval, and all those below. It's all these guys right here that we're looking at. So therefore, I get those guys. I'm going to add them up. I'm looking at 6 plus 7 plus 4 plus 2, and this ends up becoming 19. And then lastly, the final exam, an analogy. Everything that's less than the final upper limit, well, is everything in the distribution table. So we add them all up, 6 plus 7 plus 4 plus 2 plus 1, and this gives us 20. And that's nice to know because, once again, what is the total, what's the number of operations, what's the number of observations? Well, it's probably the sum of all the frequencies. And what do we do here? We added up all the frequencies. So this here should actually correspond with the number of observations. It should. The final sum. The final cumulative frequency sum. So I'm thinking, Dwayne, this is a little time consuming, writing this down. Is there ways or way for you to do this? Yes. The calculator actually doesn't really do this process. It has a different process that it does. I'll show you what is really happening. Okay. So what really is happening here is I am first thing first, there's no way I could change this situation. So this is still happening no matter what. Okay. Because that's the lowest one, and that's just itself. So 6 comes over here. But what I'm doing here is I'm going to get the previous cumulative frequency, and I'm going to add it to the current frequency in focus. So notice how we get 6 plus 7 again, and that is 13. So we just got this guy and just brought it down and added to this one. That's all we really did. Same thing, and so pretty much what we're going to end up making here is like a zigzag effect. So now I'm going to get the previous cumulative frequency and add it to the current class's frequency that we're trying to find the cumulative frequency for. So therefore, 13 plus 14 gives us 17 as well. Very, very amazing. And I'm just going to repeat the process again. Over here, add, down, and I'll get 19 again. And repeat it again, add, down to the next one, and I get the 20. And that's what's happening here. We're building upon it without having to rewrite the sum every single time. Which is something we could definitely do in the calculator, pretty simple, just 6 plus 7 plus 4 plus 2 plus 1, and these guys will naturally occur. And we'll see that. And then I'll show you how, hey, there's something that we could definitely use, and that is going to be this operation. Well, let me wait until this guy comes back. While this is happening, and I'm waiting for this one to come back up, and it's going to take a little while. I'm going to go ahead and say screw this. I'll show you how this is added up here, but we have enough information to draw a polygon, or a software, or graph, the line graph. So once again, over here we don't want to say frequency because it's not based off frequency, it's based off cumulative frequency. We want to be able to describe the graph we're looking at here. So the frequency is cumulative frequency, so I'm going to write commu for short, and frequency in short, which we know is going to be the y on the y-axis. Always frequency is always on the y-axis, and we already know that for the x-axis it's supposed to be the measurement, so it's the driving time. In minutes. That's what we're looking at. And obviously, the measurement is always in the x-axis. Or verbal data is always in the x. So now, when we come to it, we have pretty much everything we need. But over here is we're gonna have it here. But keep in mind, remember. If it was other books, we'll just use the real upper limits. But once again, our book uses boundary points. So we have to be able to convert this into boundary points, so the corresponding boundary points. And once again, how do we find boundary points? Well, all we have to do is get the midway between the upper limit and the lower limit, the the upper limit and the real upper limit. Okay, aka lower limit of the preceding class. So when I get the midpoint of these guys again, we're going to know that's going to be 24.5. And we're going to repeat the process over here. Is this the midpoint to this guy is going to be the 39.5. And I'm sure I can get on the calculator pretty cool. You guys put the boundary points, which I'm going to do. Pretty nice. And you can find the boundary points pretty simple just by looking at the lower limits. Pretty awesome. And we'll see that. So what we're seeing here is, well, that means I'm going to get the boundary points for those who require boundary points. And this here is going to become 84.5. This one here should be becoming 69.5. Over here should be becoming 54.5. Over here should be becoming 39.5. And over here should be becoming 24.5, and the one that corresponds to the lower limit is 9.5. Once again, I'm sure I'm going to go ahead and turn it on real quick, so by the time I'm done graphing our guide, it will be ready to go, and we'll make sure we graph and get everything else in there. So let me go ahead and put the boundary points for this one here, because our class is boundary points. So over here we have the 9.5. The 39.5, the 54.5, the 69.5, I knew it, I missed one. I got that one. Oh, I got 24.5. Oops. I knew I was missing something, and it didn't feel right. So over here, it's supposed to be the 24.5, the 39.5, the 54.5, the 69.5 over here. And then lastly, need more space, the 84.5. So those are the bottom points that we're using for our book. And now all we're going to do over here is get the appropriate frequency that is based off the cumulative frequency. So notice the maximum was 20. Okay, so we could pretty much try to get a graph to go based off 20. Might be possible. If you jump by 4 or jump by 2, but 2 might not be enough. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now let's do 3 more. So that's not going to be helpful. Maybe 24 will do it. But I'm going to go ahead and put 25 because I would just jump by 5s for the heck of it. Okay. So therefore, for our y-axis, we'll have 0 here. Then I put 5 right here. I put 10. There will be 15, and here will be 20. And then obviously we go up more, 25, 30, and on. Pretty much, I'm going to cap it at 25 so you can see how the graph is looking. And do the rest from there. So now notice how inside here we have 5s. So we're going to find the midway and see if it's close to the midway or not in the midway. And that would be the best way to graph these. So the first one you see here is 6. Well, 6 is definitely greater than 5, that's for sure. But we should keep in mind that the halfway marker, where's my green? The halfway marker is right here, which is supposed to be 7.5. So 6 is definitely not halfway, but it's definitely a little above 5. So we're going to definitely know for the first interval that we had in our class, this one here, it's going to be just a little bit above 5. But remember, at the 9.5, it's supposed to be 0. Because there is no 0, there is no frequencies less than the first limit, the first interval, sorry. So therefore, we have a 0 right here. And that's what we have the 0 for. And then next, we have 17. Well, 17, no, I mean to say 13 right here, bam. 13 is within this region. While halfway between 10.5 or 10 and 15 is pretty much 12.5. That's good. So we know 13 is definitely very close to that 12.5, so it's very close to halfway. So we could draw it halfway, but a little bit above halfway. Okay. There we go. Next is 17. Well, 17 is definitely between 15 and 20, and definitely, once again, if we go halfway, actually halfway between is 7.5. So we can definitely see that it's halfway, but a little bit below. So we're in the same predicament. Next, we see 19. But definitely 19 is above 7.5 and is much closer to 20. So we'll just make sure that we got it close to 20, but not on 20, because 20 is supposed to be given to the last one, which is over here. So we will just, this one seems to be a little off. There we go. And voila. This is what the origami will be looking like. So it's a stepping ladder and it stops at the max. It doesn't drop down. So now I got these corresponding to points. And there we go. And if you want the values in here, you can put the corresponding values in here, which is pretty much 0. Over here was 6. Over here was 13. Over here was 17. And it was 20. Oh, sorry, 19. And then 20. 19. And 20. Okay. And let's see, okay, let's go back to the calculator. See how I grab my calculator. So if I already got this, how would it be? So I'm going to go and turn it on. So notice here, I already saved the other one. So now I have to pretty much go to menu and start a new one. So over here, first of all, I want to get the calculator out there because I want to do some calculations to show you some interesting things. I want to make sure I open a second page for the spreadsheet. So I'll go to list and spreadsheets. And the graph will always create from it or by making a new one, which we'll be doing soon. And we're making a new one because it's a line graph. We're going to get to that first. So we're in a spreadsheet for now. Let's just go ahead and put our upper limits in here. Our lower limits in here and the frequency. And we're going to see something very interesting when we're doing this. So list 1, I'm going to let that be the lower limits for right now. So list 1 lower limits. Okay, enter. List 2, I'm going to let that be the corresponding frequencies that goes with it. And I'll label it up there too, just real quick. List 2. Okay. So I'm just trying to get organized here so I can know where things are going. So once again, this is my list 1, just upper limits, lower limits. And I'm showing you how we could use this, guys, to get the boundaries. That's my technique. I'm going to show you guys. That's why I'm including it. This one. This here will be our list 2. Okay. After we get that in there, we're going to get the boundary point. We're gonna have those guys be list 3. I'm going to see how we can get that using list 1. Okay. And then list 4 will be the coefficients. And I'm going to show you how to get that using list 2, which is the frequencies. Okay. So let me just label these guys here right now because it might be easy to label now, so I can just go back and forth and convert easily, or just have it all here. I just do everything here easier. But I'm gonna show you how things happen in the calculator first. But come over here, list 3, enter, and then over here would be list 4. Enter. So now let me just have fun showing you guys how obviously in the calculator we get these guys done pretty efficiently. So like for the cumulative sum. Well, for the cumulative sum, all we're really doing here is, or the cumulative frequency, we're just adding down. And we can just do it easily by hand in the calculator. 6 plus, first of all it was 6, right? And then 6 plus 7, enter. I got the 13 that was there. And then that's when I started just adding down, like I did over here. I'm just going to continuously add down diagonally. That's all I'm going to do. Add the next frequency into the mix. So the next one here should be 4. I'm going to add 4, and that did it wrong. Delete. I'm going to add 4. Enter. That gave me 17. Add 2. Enter. That gave me 19. And add 1. Enter. That gave me 20. So pretty much just writing that and then use switching your calculator and your inputs will get you the answers pretty quick, especially when you have bigger, nastier numbers. Okay? Efficiency will be a friend. So we got that. Let me just recap it how to like what a list is when we do this one. It's actually saying everything in the list is going to have something interesting. So let's just say, because I'm gonna be pretty much adjusting list 3 and over there in the list portion. But I'm gonna show you how it's happening here and then how it's been list. But once again, you can always store it over if you choose to. That's really your choice. But first, remember how we do list 3 again? Well, we hit list and it's supposed to be 2 actually. List 2, when we enter it, it's empty. That is amazing. Then we come over here at that label when list 2 should have, let me check. List 1, list 2. Let me make sure it's list, it might be different. List 2, enter. It is list 2. So I'm gonna go back over here and see what's douche. So once again, list 2. It's supposed to come from list 2. So list 2 and an enter. It shows me nothing. Wait, I know why. I haven't put anything in there. Haha, that's why it's nothing, because it showed that there's no list. That's me being smart. I thought I put it in there, but I never did. See how they're empty? I just labeled them. So let me just put what's supposed to be in here. The lower limits, 10, enter, 25, enter, supposed to be 40, enter, 55, enter, 70. the lower limit of the corresponding corresponding intervals. And then the frequencies that correspond with the intervals goes to this 2. And now it's going to do what I want to do. So 6, enter 7, oops, that's not what happened, escape. 7, enter 4, enter 2, enter 1, enter. Everything's set. Now, I can come over here. And we see how the list is coming up and how it's being done in reality. So I'm back at the calculator to see how things are done. So now when I do my list 2, I know it now say, yeah, now you have a list, thank you. Now it's not the empty set. So over here, this is we can do cumulative frequency. And that's under list, as it's a list operation that we're going to be seeing. So what we do here is I'm going to do menu, I'm going to go to statistics, and over here, I'm going to enter it, and I'm going to go to list operation. It's actually list operation. So enter it, and what we see right here, cumulative sum list. And that's what we're looking for. When I select that, it's going to say cumulative sum of what? What I want to be list 2. That's what I want to be, so I'm going to write list 2. I'm going to enter it. Notice how I get the exact same answers. Isn't that amazing? So now I'm going to repeat the process. So I'm not going to store it this time. Once you can easily store it over to the other one. You can store this guy over to the list over here by just pressing store or second store and list 3. But I'm going to show you how you just do it in here, and it's not the bad. The only one that had the issue that I had to figure out why is it not this approximating was about the frequency proportion. That was the one that was doing the big making damage. So I had to get outside, and then I was able to bring it in. So over here, once again, how do I focus it within here? When we're supposed to be going to this 4, the cumulative one. So what I'm going to do here is I'm going to put the cumulative frequency up here, and that's going to be, at this case, I'm going to have equals. I'm going to enter inside here. So this portion equal what? Well, I want to be the cumulative frequency of this 2. So I'm going to go and do menu again. Go to data. Enter. Go to list operations. Enter. And cumulative sum list. And now I'm put this 2 again. That's what I want to do. And wherever, don't do cell reference because it's not where I'm not doing cell, I'm getting the whole list. So that's what happens when it's cell reference. So I want to change that to variable reference. That's the whole list. And now I'm going to highlight OK and enter. And there it is, right there. And it is the same answers we have over there in cumulative frequency. Okay, took less time, much less time than running everything down like that. So now, how do I graph the ORGAC? That's the question. How do I graph the ORGAC using this information? Well, remember, I have to go from lower limit into boundary points, because that's what we did over here. Notice that. Over here, what we noticed was we got the real lower limit of each class, and we found a boundary point. The only one that we don't have the lower limit for is this guy here. And we could import it, just so you know. I could say, oh, let me just go and put it right now. Just that I don't want to do that in that list, because if I try to graph that and draw out the frequencies for that graph, it's going to be flawed. So I'm making a new list, and I'm going to just modify that new list. That's the most important thing, because I want to keep these guys consistent. So if I want to graph this histogram, I try to compare it to the polygon, I could do so without having any errors. Because once again, if these guys don't have the same frequency, the same amount of information, stopping at 5, it goes to 8 or 6, it won't go to graph it. So I'm just going to make a new list that deals with it. So how am I going to do this? Well, I'm going to go over here to equals. I'll make sure I'm in list 3. This is where my boundary points. And what we said over here, what naturally happened, pretty much what naturally happened over here, if you were to notice, that each one of these guys in the real upper limit, or the real upper limit, which is the lower limit, all we really did here was we minus 0.5 from each one of them. And we got here by minusing 0.15 over 0.5. And that's what we're going to do over here. We got the midway. So come over here to this list. I want to call upon list 2, but put in parentheses. So first thing I'm going to equal, so I can know it's inside the list. And now I'm going to put in parentheses to ensure that it comes first. So in parentheses, I'm going to write list 2. I'm going to parentheses right here, okay guys? That's at the bottom, was right here. Now I'm going to pretty much put list 2 inside, so L2 inside, now it's inside, nice. Oh no, not L2, L1, delete that real quick. L1, this will be the real lower limits, or the real upper limits over here. And I'm going to now put outside the parentheses minus 0.5. And once again, I have to be on the variable to get the whole list to activate, so make sure it is variable and enter. And look at that. We're having the corresponding boundaries that we're seeing over here, the corresponding ones. The corresponding, bam, 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 the corresponding. The only one we don't have is this one. But that's okay. What we could do is something very simple, and that is we could drop down to the very end and say, well, let's put it right there, which is supposed to be the 84.5. There you are. This operation may overwrite. Oh, let me see something real quick. I knew it. Okay. I gotta do something. I guess, let me just undo real quick. Oh crap, wrong. And I know what's happening. So let me just clear this real quick. I remember last time we had to clear this setup. If I'm gonna make a change, where we could add an insert over here last time. So what I'm gonna do here is, okay, cancel. What I'm gonna do here is, I'm gonna come back over here, and I'm gonna do what I did last time. I'm going to select it, delete, and then just call upon it again. Just rename it, and then what it does is, it knows what happened, so it's gonna get rid of this expressions right here. And that's what I'm gonna have to do something over here too, because I'm gonna have to insert. I'm gonna make some type of change to it. That's the example for it comes to our calculators, who has nspire. If you want, it's gonna have the function here, but in order for us to make any other changes, I gotta delete that expression and call back the list. So that's what I'm gonna do. So I'm gonna do menu, I'm gonna do action, and I'm gonna select the column. So it's not selected. And now I'm gonna delete the column by doing, or clear the column by doing control clear. So that's what I'm gonna do, control clear, it's gone. But that's okay, because now I'm gonna do here is I'm gonna call back that list. Just call it back. So I'm gonna do list 3. I'm gonna enter, it comes back. And now, check it out. Now I'm gonna go to the bottom, and now I can put the 84.5, and nothing happens. So what we're seeing here is, if we're going to have to manipulate this here cannot have an expression. So we could first set it up to have an expression, then set the whole column, clear it out, and just call out the column again because it's been memorized. And now they're just values. And I could now adjust and manipulate when needed. So over here, I have to watch out. If I try to insert here, it's going to say, nope, can't do it. You don't want to change the operation, and we don't want to do that. So what we have to make sure that this gets cleared out. That's what we have to do. So let me just try something here. What if I just clear it here? Control clear. Oh, checked it out. Oh, easier. I should have done that earlier. Tried it out. Haha, I learned something new. Just clear it here. Just clear them. And when you're done, just clear them. It's easier that way. And now over here, remember, over here it's not the 9.5 is supposed to be corresponding to 0. While the 24.5 is supposed to have the 6. That means I have to insert and bring this down. So what I'm going to do here is I'm going to go ahead and and press menu, go to insert, insert cell, and now it's inserted, and now right there I can put 0. And now everything is set up from first boundary to last boundary. So a quick recap, I'm going to redo this again so you guys can see what happened, because I know like, oh, the long one was pretty difficult to catch on to. Let me just do the short one again. So I'm just going to, how do we go back? It's right here, the arrow, back arrow, so I'm going to do Control Escape, and that means I'm going to undo everything that I have done prior. That's all it does. Lucky your calculator can undo unlike others, which is pretty amazing. So this is where we're at. Okay, and notice how before over here I did the long process of doing that. So let me just control all the way back to see that happen again. Control escape, control escape, control escape. So all that work we did a long time ago was pretty much for nothing. Okay, about a quick way. So what we're doing here, instead of the whole row and deleting and then recalling it back, which is a way you could do. That's the first time I learned it. I did this experience right now, and all I gotta do here is set the whole row, just go to where the expression is at, and just clear it. Control clear. So now the expression is no longer there, but this whole column is now just values. So I could now come down here like I did before and put the 84.5 there. 84.5. Oh, enter. So now it's no longer expression set, it's value set. That's what we gotta do here. So now I'm gonna do the same thing that I did before. I gotta get with the expression because I need to change here. I need to change it, I need to adjust. So I'm gonna select the expression, have it highlighted, and then I'm just gonna do again, Control clear. It's gone. So now these guys are just values, they're no longer expressions. So I can now insert here, like I would did before. So I could do menu, insert, and there's my insert cell, and now I can put 0 there, and there it is. So it's a quicker way than what I did before. I'm always trying to find a way to be efficient, so if it goes longer, I'm trying to see, okay, is there a quick way, is there a quick way? And that's how I try to become more efficient. So, but that's that. So now, let's get the OR guide to be drawn. Remember, last time we tried to do it through here, and it failed. So remember, whenever we're making any type of line graph or OR guide, any type of line graph, the best thing for us to do is to actually not start a graph from here, but actually start it from the document page. We're going to actually open the page from here. So I'm going to do Control, open the page to get the line graph to happen. So now I'm going to go over here. Don't do graphs. We're going to do data and stats. That's where the OR guide's at. Data and stats. So enter that, and notice how it's already trying to figure some things out. So over here in this region here, oh, okay, let's come over here. In this one right here, I'm going to choose the appropriate variable. The one I want is supposed to be the boundary point, which is L3. So I'm going to put L3 there, enter it, and L3 again. And over here in this region, I want to put L4, which is supposed to be the corresponding frequency, cumulative frequencies. So enter that. So notice how I'm getting the same shape that I have over here. I got the same shape right here, over in the same shape. The only thing that's missing is the line. That's the only thing that's missing. So what I'm going to do here is I'm going to come back over here and input the line. So that's under menu, the plot properties. Anytime I'm trying to adjust the properties of the plot, we go into properties, enter, and it says right here, first option, connect data points. And that's the line. So I just enter it, and there it is. If I need to rescale it to keep consistent to the other ones, so we can see if it's consistent to the polygons and histograms. Once again, that's menu. I go to window and window settings, and I just adjust it to be appropriately. So over here, the min. Now this is what I like right here. This is min. So now I wish they could scale in here. I wish, because I could just control the scale to be what I want, not what the calculator ones. Over here, we could put x min 0. Over here, x min, we could put this, make this 100 like we did for the histograms. Over here, I guess we leave it as negative 2 so we can see the line where it is, because usually it's supposed to be negatives for other graphs, other calculators, we want to be the negatives. And over here, we had, ours was 25, so we can make ours 25 over here. So try to use, because this is what we had in our, over here in our graph. And I can now enter it. And now it looks pretty much similar to what we had graphed. A little more scaled out, and we can see how. And if we want to put 20, you put 20 there in reality, because it actually going to the 20 that we have, but 20 is like really right here. It does its own scale. I wish I could do my own scaling, and 20 will be in the scale of 5, but it's not doing that, sadly, on ours. The other calculators, I could control the scale, and that's what I would rather do, control the scale. But anyways, this is cumulative frequency, and the corresponding OR guide that goes with it. I know your book doesn't have you gotten OR guides, but get the practice. I mean, you always get the practice in there. Not a difficult graph to do in reality, and pretty much practice cumulative frequency. That's the one that's asking us to do our focus on, and the purpose in your homework. Okay, so stay tuned for other graphs that I'll be making for you guys to watch, and it's going to be just pretty much the bar graphs, the stem plots, the dot plots, and that's it. Okay. The intensity plot, that's also there, but that's easy to do.